In this episode, we're going to look at deploying a .NET 6 Web API to a load balanced cluster of EC2 instances in AWS. Hey everyone, Wes here with Productive Dev. I hope you're doing well. I'm super excited about this episode because we're going to do a deep dive into some AWS infrastructure. We're going to look at how to take a .NET 6 Web API that was built using test-driven development and containerized, and look at how we can deploy that to a load balanced cluster of EC2 instances in the cloud. We should be able to watch logs basically alternate left and right here, confirming that our load balancer is working. So we'll refresh. We see the right side, the left side, and we can see this load balancing round robin style between the two EC2 instances in our target group. So in episodes 1 and 2, we built this .NET 6 Web API using test-driven development. In episode 2, we Dockerized this image and we looked at how we can run our Web API using Docker. And now we're going to look at how we can deploy this image to a number of different virtual machines in AWS. So conceptually, we're going to start with the creation of a VPC. So we'll look at how you would create a VPC in AWS. From there, we're going to look at how we can set up subnets in our VPC in different availability zones, which is going to increase the availability of our web infrastructure. With 2 availability zones in place, we're going to create an application load balancer. This application load balancer is going to be very simply configured to deliver traffic in a round-robin fashion to 2 instances of our containers running .NET, each in a different availability zone. So as we dive in and build this project out, we're also going to cover a lot of really interesting topics related to developing for AWS and developing for web workloads in the cloud. So for instance, we're going to talk about some security considerations when we look at creating and configuring various security groups. We'll also talk about things like a NAT gateway, which is going to be used to allow services in our private subnets to access the internet while not allowing traffic from the internet to actually reach any of the resources in our private subnet. We'll talk about routing tables and how to make sure that our public and private subnets are set up properly, either with a NAT gateway or an internet gateway. We'll also talk about configuring IAM roles so that we can basically set permissions properly on the services that need to, say, pull Docker images from ECR. So we'll talk about ECR, which is the Elastic Container Registry. Finally, at the end of the video, I want to make sure that you can tear down any of the resources that you create. So I'll show you how to basically tear down everything that we work on in this video, just to make sure that you're not leaving any resources provisioned and that you may be paying for beyond the scope of what you'd like to learn in this video. So I'm super excited about this video. I hope you learned something. If you run into any issues, be sure to leave comments or questions below. Also, if you'd like to see how we actually built this .NET Web API from scratch, then I'd recommend checking out episode 1. If you need to know how to Dockerize it, check out episode 2. And otherwise, if you'd just like access to all the source code, patrons of the channel via Patreon get access to all of the source code that's created on Productive Dev. If you do decide to support the channel via Patreon, I'm incredibly grateful for your support. And in any case, whether or not you're a Patreon or not, I do really appreciate your viewership, and I hope that you're able to learn something from this and other videos. So thanks for watching. Let's get started creating our new VPC on AWS. Okay, so let's get started setting up a VPC to host our web infrastructure. So before we do that, something that I'd like to do is to set up an Elastic IP address. We're going to use this Elastic IP address to associate it with a NAT gateway. And so we'll talk about the NAT gateway in a little bit here, but one thing to note is that the NAT gateway is going to require an Elastic IP. So we can set that up by visiting EC2. And if you don't see that on your dashboard, you can search for EC2 in the search bar, and we can visit the dashboard. Now we can head over to Elastic IPs here if you see it in resources. Otherwise, if you scroll down On the left side, under Network and Security, you can also see Elastic IPs here. So we're going to allocate an Elastic IP address. One thing to note here is that IP addresses are a scarce resource, so be sure to release this address if you're not using it for anything. For one thing, you'll be charged for not using it, and for another thing, it's a good habit just to go ahead and release that back into the pool of available addresses so that you're not sort of hanging on to IP addresses that you're not using. Okay, so we're going to leave everything the same here. You can see this is going to pull from Amazon's pool of IPv4 addresses, and we're just going to click Allocate. So within a few seconds, AWS is going to allocate a public IP address for us. So this Elastic IP address is static, meaning that it's not going to change. And so this is going to be really useful for us when we're setting up any number of different resources we might put in a public subnet, so something that's going to be accessible from the public internet. In our case, that's going to be a NAT gateway, and so we'll look at that shortly. I'm going to go ahead and name this NAT gateway demo, and we'll save this. And now we're ready to head over to the VPC dashboard. So for that, you can type VPC, and we'll head here. And what you'll see here is a number of different resources that we can manage related to VPCs. For now, we just need to focus on creating a new VPC for our web infrastructure. And a really convenient tool that AWS has for us to create a new VPC is this VPC wizard. So we'll select Launch VPC Wizard. And now we're going to select VPC with public and private subnets. So you can see from the diagram here, basically the idea is that we're going to create a VPC, which you can think of as a sort of virtual data center. It's a virtual private cloud, so it's sort of a small section of Amazon's cloud that you're going to use to provision your own resources and to network them. And so in terms of networking, it's going to create a public subnet for us, which will contain a small number of resources that we need to have public facing to the internet. And so this includes things like our load balancers and a NAT gateway in this case. And then the private subnet contains usually the bulk of our infrastructure, things like our web servers, our application servers, and things like database servers. So all of these are basically shielded from the public internet. They're not publicly addressable, and they won't have public IP addresses associated with them. They will, however, be addressable within the VPC via private IP addresses, which is what we'll set up shortly here when we look at subnets. So the purpose of a NAT gateway is to provide outbound traffic from resources in our private subnet to the internet. But it prevents us from being able to have those resources connect back directly to anything in our private subnet. So when we have services like web applications and database applications and things like this in the private subnet, those resources will be able to reach out and access resources on the internet using the NAT gateway. So those HTTP requests will be routed through the NAT gateway out to the world, but it's sort of one-way traffic. We have no way for the broader internet, rather, to make a connection back to resources in the private subnet. So I hope that makes sense. We're going to click Select now. And now we're brought to a screen where we're going to set up our public and private subnets. First of all, we'll give our VPC a name here. We'll call this .NET Apps Demo. And now we're going to set up the range of IP addresses for our private and public subnet. So you can think of a subnet as being defined by a range of IP addresses. And when we're talking about ranges of IP addresses, one way to represent those ranges is using CIDR block notation. So CIDR block notation basically consists of two parts. We have a prefix, which is an IP address here, as you can see, IPv4 address in this case, and then a /, and then a number, and this number is called the prefix length. And so basically, the way you can think of it is the higher the number here, at a very high level, the higher the number, the smaller the range of IP addresses, starting at the prefix address. And the lower the number, the greater the number of addresses. Basically, this just helps define a mask over which there's a range of matching numbers. So, for instance, IP address 10.0.0.0/24 gives us technically 256 IP addresses. Now, you'll see 251 IP addresses here to make this a little bit confusing. AWS actually reserves 5 addresses from any subnet for its own purposes, and this includes for things like reserving the network broadcast address, which is at, in this case, 10.0.0.255, the network address, which is 10.0.0.0, and a few other addresses that it uses for its own internal purposes. So 256 minus those 5 addresses leaves us with 251 available IP addresses defined by this CIDR block. And if you're interested in seeing what that range is, I won't get deep into the way that the prefix length is calculated, but we can see if we have 10.0.0.0/24, prefix length of 24 here, we can see this gives us the 256 addresses between 10.0.0.0 and 10.0.0.255. If we were to make this number higher, say 32, this basically means that we have to match exactly the prefix, all bits of the prefix, and so we have a start and end address of exactly the same number, and so this is defined as one IP address. If we were to go lower, say 16, we get a much broader range of IP addresses starting at 10.0.0.0 and ending at 10.0.255.255. So that's the basic concept. So we're going to get 256 minus 5, so 251 IP addresses for our public subnet, and we're going to set this in availability zone US East 1A in my case. I'm going to call this public subnet 1. And for the private subnet, we now need to define a range of IP addresses that doesn't overlap with our public subnet. And so we'll just go to 10.0.1.0/24, and you'll see that that effectively takes us from 10.0.1.0 to 10.0.1.255. So we'll use this for our private subnet. And again, US East 1A, we'll call this private subnet 1. And now we need to tell AWS when it creates our VPC for us here what elastic IP address it would like to, or we would like to use rather, for our NAT gateway. So we're going to select the IP address that we just allocated. Again, the NAT gateway allows resources in our private subnet to make contact, to make requests to the public internet, and it allows that one-way outbound traffic. Okay, we're going to go ahead and create the VPC now. This should take about 3 minutes, and so I'm going to pause the video here, and once it's done, we'll pick things back up. Okay, so you can see our VPC was successfully created, and we can take a look at it if we just visit the Your VPCs link. We can see we have, in my case, I have 2 VPCs. This is the default VPC created with this particular AWS account, and then we have a .NET Apps demo, which was the VPC that we just created, and we can select the VPC ID to get more details about this particular VPC. Now, when the VPC wizard ran, we created several new subnets. We created a private subnet and a public subnet, and we're going to set up a load balancer, and in order to basically increase the availability and resiliency of our infrastructure, we'd like that load balancer to use at least 2 different availability zones. And so our private and public subnet here are in the US East 1A AZ. And so we'd like to set up a new private and a new public subnet so that we have a pair of public and private subnets, each in a different availability zone. And this is actually pretty simple to do. So we can do that by selecting subnets from the left menu here, and then we're going to select Create Subnet. So here we need to make sure that we select our new VPC, which in my case is this .NET Apps demo. And let's call our first one Private Subnet 2. We're going to choose a different availability zone than the one we chose for our first subnets when we ran the wizard. So I'm going to select US East 1B here. And now we need to select yet another range of IP addresses using CIDR block notation that don't overlap with either of our other subnets. So here I'm going to do 10.0.2.0/24. So this is a new range. Previously we've used 10.0.0 and 10.0.1, and now we're using 10.0.2.0/24. And we'll now add a subnet again, this time for our second public subnet. So we're going to call this public. And again, I'm going to use US East 1B here. And we're going to put this in a new range, 10.0.3.0. And we'll go ahead and create these two subnets. Now by default, these are going to be private subnets associated with that NAT gateway in terms of reaching the internet. So we need to update our routing table for our public subnet. And so if we click the subnet ID for our new public subnet, and we scroll down to the route table, we'll see the destination route, the destination for the route 000/0, which represents all IPv4 addresses. The target is the NAT gateway. We need to change this to be our internet gateway, which was created for us when we created our VPC, and this is going to allow communication with the greater internet. So let's go ahead and change the route table. Well, we're visiting the NAT gateway now, so we'll go back. Let's go ahead and once again go to the route table, and we'll edit the route table association. Here we're going to select the route table that contains our internet gateway target, where the destination route is all IPv4 addresses. So we're doing this for our public subnet, our second public subnet. We'll save. Okay, and so now if we head back to our subnets, and I'm going to order this by VPC, we can see the 4 subnets that we've created. The first 2 were created with the wizard, so public and private subnet 1. And public and private subnet 2 were created just now when we ran create subnet. And we can check to make sure that the routing looks correct. What we'll do is for public subnet 1, we'll click the subnet ID and scroll down, look at the route table. And we should see our internet gateways. We should see IGW as the target for the destination 000/0, which is all IPv4 addresses. We'll go back. We'll take a look at public subnet 2. In the route table, this is the one that we just updated. Also pointed to the internet gateway. And then our private subnet should both be using the NAT gateway. So we'll come down to the route table for this one. You can see the NAT as the target. And now we'll go to private subnet 2, scroll down the route table. Again, we see the NAT. So again, this is allowing outbound traffic from our private subnets here. So basically resources in those private subnets should be able to reach out to the internet by having those requests routed through the NAT. Okay, so with that, we've now set up basically 2 pairs of public and private subnets, and we can go ahead and create a load balancer that we'll use to balance traffic across application instances that we'll be running. So for this, let's head over to EC2, and we'll scroll down to load balancers, and we're going to create an application load balancer. So we'll select create load balancer, and we're going to select application load balancer. This is a really fantastic, very advanced load balancing resource. This lets us basically route HTTP and HTTPS traffic, and as you'll see here in a moment, we can actually have it route to IP addresses or specific EC2 instances or even Lambda functions. Let's call this the .NET Apps ALB demo. It'll be internet facing IPv4, and we need to select our new VPC. And now that we have mappings in 2 availability zones, we should see those here. And you can see that AWS does recommend selecting at least 2 AZs. This is for increased availability of our application and resiliency. So we'll select US East 1A, and if private subnet is selected, you'll see we get a warning that we need to have a route to an internet gateway, because our load balancer is of course going to be internet facing. So we'll select our public subnet. So that looks good. And US East 1B, our public subnet, which should now also have a route to our internet gateway. We're going to leave the default security group. We'll talk about security groups more in a moment. And for now, we're going to listen on port 80. So it is best practice here to set up an SSL cert that we would put on our load balancer for handling HTTPS traffic on port 443. But for now, we'll stick with port 80 to get started. And basically what's going to happen is we are going to listen on port 80, and that traffic is going to basically be balanced against a target group. And so we don't have any target groups created yet, but if we select the create target group link here, this will open up a new tab for us. And as you can see, we can create a target group for instances of EC2 instances, IP addresses, or even Lambda functions or other application load balancers. But we'll call our target group here .NET Apps TG for .NET Apps target group, and we'll call this demo again. And we're going to set this to HTTP port 5000, where our .NET Apps will be listening. And again, the .NET Apps demo is selected. We'll use protocol HTTP1. And for health checks, if you saw episode 2 of Productive Dev, when we were Dockerizing our .NET Apps, we added a health check at /health for any of our .NET services. And so we're going to use that health check here as well. We can see advanced health check settings here as well. We're not going to worry about that for now, but we do have a simple health check exposed at /health, so we'll use that. And I'll select next. Oops, and for target group name here, we need this to actually not have spaces in it. So we fix that, and next. We don't have any instances available to register yet, but we can register them later. We'll just go ahead and create our target group. And you can see I have an old demo here. We're going to delete the old target group just to avoid any confusion. You likely won't have one in yours if you haven't set one up yet. You can see we don't have a load balancer associated with this new target group. So let's go ahead and associate one now. We'll head back into the load balancers tab. If we don't see it here, just hit the refresh button. And now we see our new target group, and we should be good to go. So basically, the load balancer is going to be listening on port 80, and it's going to be forwarding that to traffic to our applications that are running in this target group and listening themselves on port 5000. Okay, we won't worry about add-on services for now, and you can take a look at the summary. We'll go ahead and create our load balancer. And our load balancer name also should not have spaces in it, so apologies for that. Okay, let's go ahead and see if this works now. We'll create the load balancer. Okay, so this is now getting created. Note that it will take a few minutes here for it to be fully set up and routing traffic. We can go ahead and view it, and you can see that it's in a provisioning state. So now what we should do is basically provision some EC2 instances that we can add to the target group. We're also going to set up a small jump server that will allow us to essentially SSH into our VPC, and then we're going to forward our SSH connection into the private subnet where our application servers are running. So this way we can actually get a shell on our private servers, which don't have public IP addresses, via this jump server. So I'll show you how to do that now. We'll head back into the EC2 dashboard. And so now we're going to head over into instances, and we're going to launch an instance for our jump server. Now for this, I'm just going to use Amazon Linux. So we're going to select this, and I'm going to use the free tier eligible T2 micro instance. And we can configure details here. We need to make sure that we put this in the correct VPC, so I'm going to put this in our new VPC. And for this jump server, I'm going to put this in our public subnet, and we're going to auto assign a public IP for our jump server. Our jump server's sole purpose is just to enable a developer to SSH into our VPC and to access any of the various resources that might be addressable via internal private IPs in the VPC from the jump server. Okay, so we will leave the other settings to be as they are, and we'll click Add Storage. We'll leave this at 8 gigs. We can add tags if we like. We'll configure a security group now. So with a security group, you can kind of think of this as a firewall. And essentially, it allows us to configure the various protocols and port ranges and source IP addresses that we want to allow to any particular resource. And so we really want to lock down our resources as much as possible. For one thing, we're using SSH for security, but if our security group allows anyone with an SSH key to connect, which is what we have set up here, then that means if for some reason your SSH key is somehow compromised, then anyone from any IP address around the world would technically be able to SSH into your jump server. And so one of the ways that we can kind of harden this down is by allowing only specific IP addresses to connect over SSH. So for this, if you click source, you can just select my IP address, and you can see what you'll have here is your IP address represented as a CIDR block. So we have /32, meaning the single IP address that is listed as the prefix. You can of course specify a range of IP addresses. I'm going to call this West SSH. So we're allowing connection from my IP address on port 22, which is the default SSH port. And there are many different protocols and types of protocols that we can allow here. Okay, so for now we're going to basically lock this down. If we want to add other rules where we say add other developers or any other rules that we might want for the jump server, we can add those as well. But for now, we're just going to lock it down to SSH from my computer. So we'll review and launch. And so we can see we're spinning up an Amazon Linux 2 AMI on a T2 micro instance, and we have a pretty secure security group here allowing SSH only as inbound from my IP address. So we'll go ahead and launch. It's going to ask you to create or select an existing SSH key pair. So if you don't have one, be sure to create one. And this is going to be required for us to actually connect from our development machine into the jump server. So that's really important. We need to make sure we acknowledge that we have access to this particular key, and we'll launch our instance. Okay, so we'll see that our instances are now launching, and we can go view instances, or we could just click on the instance ID and we can see that it's pending. So within just a few seconds, this will reach a running state. While that's happening, we can rename it. We can call this .NET demo or .NET jump demo. And you can see we have an instance state of running. So if we want to connect to this instance, we can select connect here. So you can see here, we have an example SSH command to connect to this instance on its public address with the key that was set up. So we need to make sure we, again, have access to that private key. And of course, you're going to want to make sure that you have an SSH client installed on your development machine. Okay, we'll worry about connecting to this a bit later. Let's go ahead and finish setting up instances that we want to load balance against as well. So for this, I'm going to go ahead and create one more instance. We're going to launch an instance. We're going to place this one in our private subnet, and it's what's going to be running our .NET container. So we'll select an Amazon Linux again. Again, we'll use a T2 micro. And here we're going to put this in our new VPC, and we're going to leave this in a private subnet. So I'm going to put this in private subnet 1. And we're going to not auto-assign a public IP. This will not be addressable from the internet. We'll add storage. We can leave this at 8 gigs for now. We can add tags if we like. Now here, we want to be able to SSH into this particular server only from the jump server. And so one way we can do that is by moving this into a security group. Okay, so this security group is named Launch Wizard 1. We'll go ahead and copy the name. We probably should have named this something more descriptive. We'll come back and basically what we're looking here for is this Launch Wizard 1 security group. So we'll select this, and this is SSH from West SSH SG. So we're saying anything from this security group can SSH into our new web app server. We'll call this one web apps SG, and we'll say SSH from jump to web app servers. And we'll review and launch. Go ahead and launch our new instance, and I'm going to use the same key. Okay, and I'll click on the ID for this, and we'll rename this .NET Demo App 1. Okay, and just in a moment here, this will also be running. So now what we need to do is we need to get a shell on this particular instance, and we'll look at how to do that via the jump server. And we want to install Docker on this app server so that we can actually run the Docker container, the Dockerized version of the .NET API we're running. So now that it's running, I'll show you how you can get set up so you can forward your connection to this private server. Okay, so again, as usual, for these productive dev videos where I'm working on Windows in particular, I'll be using Windows Terminal, and as a terminal emulator, I'll be using Git Bash. And I have an SSH client installed. And so if you don't have an SSH config file, I'd recommend creating one. You can find this, or rather you should place this at your home directory and then .ssh and then config, and feel free to create this file and directory and edit this in your preferred text editor. I'm going to just use Vim here. And you can see what I've set up is an initial set of hosts. This is going to provide us with a really convenient way to SSH into, first of all, our jump server and any application servers that we access via the jump server. So this host entry for demo jump will allow us to basically run the command SSH space demo underscore jump and connect to the particular host that's defined in this config file. So this is an old host file. So what I'm going to do is get the new IP address for the jump server. And we're going to come back to our EC2 dashboard. I'm going to go to the dashboard and look at running instances. And I'm going to get the public IP address for our .NET Jump demo. So I can see that here. I'm going to go ahead and copy this. And we'll come back to our file here. And we'll paste in that public IP address. Okay, the user will be EC2 user for these Amazon instances. If you're running an Ubuntu server, the user is typically Ubuntu. You can check that. If we open up the connect dialog again, you can see that in our case it's EC2 user connecting over SSH here, so just be sure to use the correct user. And then we have two host entries, Demo App 1 and Demo App 2. For now we've set up a single app server, so we want to get the internal IP address for this. Again, it doesn't even have a public IP address, so let's grab that. We'll head back into EC2 and look at our running instances. And we'll look at .NET Demo App 1. Again, no public IP address, but we do have a private IP address at 10.0.1.121. So we'll go ahead and set that as our host name. And again, EC2 user is the user with the same private key on port 22, which is the default SSH port. And now we have this new directive called proxy command, which is basically going to SSH into this particular server via the jump server, so via demo jump here. And so by running the command SSH space demo app 1, basically our config file is helping us proxy that SSH connection directly to our private network. And we don't need to store our identity file. We don't need to store our private SSH key anywhere in the public subnet. This just remains directly on our development box. Later, when we set up our second app in just a few minutes, we will change the host name here to match the correct host name for the second server. Okay, so let's go ahead and save this. So save the file, and we can test that it works we can first of all run SSH demo jump. And you can see that for the first time we connect, it needs to make sure that we want to continue, and this is going to add this to our list of known hosts. You can see now that we're connected, we see the EC2 Amazon Linux 2 AMI, and we can see where we are. We're in home EC2 user. Okay, so that's good. We can make sure that we have access to reach out to the public internet, at least from the jump server. So if we ping aws.com, we can see things look good. We can ping google.com and things look good. Okay, so let's go ahead and disconnect with Control D. And if you recall, back in our config file, we had a host entry for demo app 1. Let's try to SSH into demo app 1. We're going to get the same question here, whether or not we want to add this to known hosts, and we'll say yes. And so now we're actually connected to our app instance, which is not addressable from the public internet, but since we jumped into the jump server, which is in our public subnet, and then SSH'd from there into the app server here in the private subnet on its private IP. Okay, so we'll disconnect here as well. And now our next step is basically to install Docker on this app server. So in fact, we didn't need to disconnect. I'll SSH back in here, and we'll run the various commands that we need to run to install Docker. So for this, we're going to use yum, and we'll sudo yum update. We're going to sudo yum search Docker to search for the Docker package. And we'll run sudo yum install Docker if everything looks good. And we'll say yes. Okay, so now that that's complete, let's go ahead and enable the service at boot time. So for this, we can say sudo systemctl enable docker.service, and we'll sudo systemctl start docker.service. And oops, need to fix a typo here, systemctl. And now we can check to make sure it's running with sudo systemctl status docker.service. And we can see that Docker is indeed running. So now if we want to be able to run Docker without using sudo, we can add our current user to the Docker group. So we can do that, first of all, making sure we have the Docker group, which it should already exist after the install. Now we can user mod -a capital G Docker, our current user. And now we can Control D to log out and SSH back in. And if we run Docker PS, this should now be possible to run without sudo. Okay, if we want to verify that Docker can run at all, we can do docker run hello world. And it's going to pull hello world, and we can see that Docker is running properly. Okay, so essentially our app server is ready to run a Docker image, and so it's ready to run our .NET API. Now we need to figure out a way to basically get the Docker image onto this particular server. And one way we can do that is by pushing our built Docker image that we created in episode 2. We can push that to ECR, and then we can create a user that has permissions to pull images from ECR directly onto this particular server and then run that image. So let's look at how to do that now. So I'm going to go ahead and exit with Control D. And you recall that in this directory we have a Docker file. And we can clearly build this Docker file, that's fine. What we want to do is actually push this to ECR, which is Amazon's Elastic Container Registry. You can sort of think of it as a way to create a private Docker hub for any of the applications that you might want to manage. So we'll head back into the console. And we're going to search for Container Registry, or ECR. And I'm going to star this, and we'll head into the container registry. Now you can see that I have an old image here. I'm going to go ahead and delete this one. And we're going to create a new repository from scratch. I'm going to call this .NET Users API. And we'll make sure that it's private. And we'll keep all the other settings the same for now. We'll go ahead and create the repository. And so if we click our repository, we can see we have no images associated with it yet. We can see the push commands here. So here we can see that there's a number of steps that we follow. If we're on Windows, then we have what looks like some PowerShell commands here. Since we're running git bash, we can follow along with the macOS or Linux commands. Basically, we're going to get an auth token, which is going to authenticate our Docker client to our registry. This is going to allow us to build our local image and push it to our ECR repository. So for this, we want to make sure that we have an AWS user set up. And so what we're going to do is head over to IAM, and we're going to set up a user specifically for this purpose. So we're going to go to IAM, start this as well. And you can see I have a user group already created with ECR power user. But we'll create this from scratch just to see how things work. We'll create a new group, and I'm going to call this .NET Demo Devs, or in my case, I'll just call it Productive Devs. And we can add users to a group if we have one. Let's imagine we don't have any users yet, so I'm just going to create the group itself. And the first permission we're going to give them here is ECR. We'll search for this. Don't see it here, so let's look for container. And if we scroll down, we see Amazon EC2 Container Registry Power User. This is a set of permissions that allows, it looks like, basically read and upload, access, and putting an image, but it doesn't actually allow us full admin control or full access, which we could see contains some additional, or rather all privileges here. We're just going to use the EC2 Container Registry Power User permissions. Okay. So we'll go ahead and create the group. So now we see we have Productive Devs. If we click into Productive Devs, the group, we don't have any users in the group. As far as permissions go, though, we have our EC2 Container Registry, which is ECR power users. So we can have full access to repositories, but it doesn't allow for deletion or policy creation. So this looks like what we want. We want to create a new user now. So let's go ahead and select Add Users. Actually, if we head over to Users on the left side, we can visit it here, and we can click Add Users as well. And I'm going to call mine Wes/dev, and we want to set up programmatic access. Okay, so this is going to give us an AWS access key and secret access key. We go to permissions. We're going to add it to our Productive Devs group. We're going to go to tags. We're going to skip tags for now, and we're just going to create this new user. So when we do this, as mentioned, we're going to get an access key and a secret access key. So we definitely want to keep our secret access key secret, and we generally want to operate on the principle of least privilege, meaning that we don't want to give any more privilege than is absolutely necessary for a particular user to do their job than is necessary. And so right now we're just operating under the assumption that all this user really needs to do at the moment is the ability to push and pull images from ECR. And so that's why they belong to the dev group, whose only current permissions are to be able to push and pull images from ECR. But anyone with the secret access key and the access key can basically act as this user on their behalf. And so we definitely want to keep the secret access key secret. So let's set this user up on our local machine. So I'm back on the local machine. For now, we're not connected to any of our EC2 instances. And I'm going to run the command AWS configure. We're going to call this profile Wes/dev. So it's going to ask us for an AWS access key. Let's head back into our screen here. We're going to copy this. And there we go. It's now going to ask us for our secret access key. So we'll copy this and paste this. Default region name, I'm going to set to US East 1. And default output format, I'm going to set to JSON. Okay, so what we have now is a profile called WestDev that is utilizing the access key and secret access key that we just created for our new user. We can check out where this data is now stored locally. If we head to AWS credentials, so this is in our relative to our user directory, in other words, our home directory here, .aws/credentials. We can see that we have a new entry here, WestDev, with the access key and secret access keys set up. Okay, so that's basically all we need. And now we're ready to push our image to ECR. So first of all, let's make sure the latest version of our Docker image is built. So we'll run docker build, and we will use our productive dev /cloud customers latest in our project directory where our Docker file is. Okay, now we're going to run docker tag, and we're going to say productive dev, so the name of our image, cloud customers latest. And now we need to get our repository that we just created. So for this, we'll head back into the console and we'll go back to ECR, and you can view in the push commands here. Basically, we want to grab this string here. So we'll copy this. This is going to point to our repository name. And now we need to log into ECR. So for this, we're going to use our new profile. So we're going to say AWS ECR get login password region US East 1 profile, and we're going to say WestDev or whatever you named your profile. We're going to pipe that to Docker login with username AWS and password standard in. And then this is going to be the URL to our repository. We can come back and get that. We can view push commands to actually get that again. The only difference between their login and ours is that we're specifying a profile. So we'll go ahead and grab the password here. Rather the URL, this is not the password. Okay, and we got login succeeded, which means things are set up properly. And now we can push. So here we're going to docker push. We're going to copy the URL again. Oops. Need to put the suffix here, which again we can get from here. So .NET Users API latest is what we named the repository. Okay, let's go ahead and try to push. And so now we're successfully pushing our image up to AWS and specifically Amazon ECR. Okay, so now that our image has been pushed, if we visit the ECR console, we should be able to actually see it. So if we just refresh here, we can see that our image tagged latest has just been pushed up to our repository. Okay, so now that we have the image pushed to ECR, we need to be able to pull this from ECR onto any of our app servers. And you might be tempted here to use the same AWS profile that you used for your developer user, but I would highly recommend not doing that and creating a new IAM role or user, which just has access to pull images from ECR and is not associated in any way with your developer group. After all, your developer group may expand in its functionalities over time and basically get more privilege, and privilege that's not required at all for an app server just to pull a simple ECR image. So it may seem like an extra step here, but I think it's probably best practice for us to, again, operate on the principle of least privilege and to think ahead a little bit. And so for that reason, we're going to create another IAM user here. So we'll come into users, and we're going to call this ECR agent. Actually, we need to add the user, sorry, not search for it. It's going to be called ECR agent. And again, access key, programmatic access, permissions. We aren't going to add the user to a group, but we're going to attach an existing policy directly. And we're going to look for container registry again. And we're going to give this ECR agent read-only access to the ECR. And we'll say tags, review, basically a read-only ECR agent. We're going to go ahead and create this user. Okay, so leave this open, and we're going to need to set up a new profile, this time on our app server, with this access key and secret access key ID. Okay, so we'll head back here. We're going to SSH into demo app 1, and we're going to say AWS configure profile ECR agent. And so we're going to use the access key that we just created. Copy this. And again, our secret access key. Default region name, we'll say US East 1. Default output format, we'll say JSON. And so now again, we can actually just take a look at our AWS credentials, and we can see that we have an ECR agent user here. So this means that we should be able to log into ECR and pull our image. So let's take a look at how we can do that. We'll head back into our ECR console. So back in our ECR console, if we want to pull this image, again, the login is the same here. So we would actually just use this command, except we would specify a profile. So let's go ahead and do that. I'm going to go back here. And we can see that the login has succeeded. And for additional security, we could configure a credential helper so that our password is not stored unencrypted on this private server. And basically, we can just run the docker pull command now, and we just need to pull from the repository URL. So we'll copy this, paste here, and we'll pull latest. So you can see we've pulled latest. And if we run docker image ls-a, we can see now we have our hello world instance that we pulled, but as well we have our new .NET Users API image that we pulled also. Okay, so let's go ahead and docker run this image just to make sure things are working. And we can see that our .NET application actually starts up. Okay, so something that I want to do here is we can close and with Control-C here, and then if we docker ps, we can see that the container is stopped as well. What we want to do now is run a command that basically exposes our API on port 5000, and our load balancer is going to basically send traffic to this instance when we place it in a target group. And we can actually just duplicate, images that we have here of this particular EC2 instance and place those as instances in our cluster in the target group as well. So this is why I'm setting up everything on a single EC2 instance to get started, and then we can basically create replicas of those using the same image on new EC2 instances. All right, so let's go ahead and run our image, except we're going to run it with some additional flags here. So we're going to run --rm to clean things up, and then we're going to expose port 5000, map that to port 5000, same for 5001. We're going to set ASP.NET Core HTTP port to HTTPS plus 5001. Again, we covered this in episode 2, but we're doing the same here. ASP.NET Core URLs is equal to HTTP plus 5000 and then our image. So let's go ahead and try to run this. Okay, so we can see we're listening on port 5000. Now let's see if we can add this EC2 instance to a target group and actually hit our application from the public internet. So let's come back and we're going to go back to EC2 and we're going to go visit our load balancers. So if we scroll down and click load balancers, let's go ahead and take a look at the listeners. And we should see a target group here. So let's go ahead and view this, forwarding to our target group. So we'll visit our target group and let's register a target. So we're going to register our .NET Demo App 1 and include as pending below. Okay, so this is going to forward traffic to port 5000 on our demo app, which again is running in our private subnet, and it's pending. We're going to click register pending targets. And in a moment, we'll see whether it's healthy or unhealthy. Should be healthy because we have a /health check endpoint. And it's interesting, the health checks can be configured. So we have a timeout of 5 seconds with an interval of 30 seconds, and the healthy threshold is on 5 consecutive health check successes. And if we get 2 consecutive health check failures, we have an unhealthy target. And you can see that right now we are getting an unhealthy target. So one thing we can think about is, why might a request be timing out? And if you think about it, we have set up our instance without actually altering or creating a security group that allows traffic on the port that we're trying to hit here. So let's adjust that. We'll leave this open, and I'm going to head back into the EC2 dashboard. We're going to go to our instances, and we're going to look at .NET Demo App 1. And if we scroll down to security, we can see we have our web apps security group, which is allowing inbound traffic on port 22 from a security group that we set up for our developers. Let's now also allow inbound traffic on port 5000 and 5001. So what I'm going to do is edit this inbound rules. We're going to add a rule for custom TCP 5000 to 5001 from anywhere. And we'll call this .NET Web API ports, and we'll save those. Okay, so now we allow inbound traffic via the security group that's attached to our web application. So we'll head back to our target groups and we'll refresh. And after a few seconds, we see that our target is now healthy. So that's good news. That means that it looks like things are probably going to work well for us. What we're going to do now is to create an AMI of the .NET Demo App 1 EC2 instance that we created earlier, and we're going to add a second EC2 instance that's essentially the same image running on a separate VM to our target group. So what we'll do here is I'm going to go to Actions, Image and Templates, and we're going to create an image. And we'll call this image Docker Web App Demo. And we'll keep all else the same here. And we'll go ahead and create the image. So now if we visit AMIs, we can see that the status is pending for creating this image. Once that's done, we're going to spin up a new EC2 instance using our custom AMI here, which already has Docker installed, and in our case also has our .NET Docker image pulled. Okay, so the last thing that I'd like to do here is to ensure that our load balancer can not only communicate with the registered targets that we have on port 5000, but we need to make sure that traffic can go both ways there. So what I'm going to do is create a security group for our Elastic Load Balancer. So I'm going to call this ELB demo SG. And we're going to say allow traffic to and from target groups, or TG. We'll make sure that the VPC is indeed our new VPC. And for inbound rules, what we're going to allow here is HTTP traffic from anywhere. And we're also going to allow custom TCP traffic from 5000 to 5001 from anywhere. And then we're going to go ahead and create this security group. Okay, with this created, let's head back into our EC2 dashboard. We're going to go down to our load balancer. And here we're going to edit the security group for our load balancer. So we'll click Actions, Edit Security Groups, and we're going to remove the default VPC security group and select Allow Traffic to and from our target groups. With that saved, we can go ahead and copy our DNS name, and let's visit this in a tab. So we'll do /users, and we can see that we get our users now load balanced to our single EC2 instance. So though technically we have a load balancer set up, what we need to do is to add another EC2 instance to our target group, and we can see how the load balancer will balance traffic against both of those instances. So to do that, let's head back to our EC2 management console. We can go to our EC2 dashboard and click on our running instances. Now you could go through the steps of basically setting up Docker on a new EC2 instance just like this one, and then SSHing into that using an update to our SSH config. And we will update our SSH config. Another thing we could do is we could create an AMI of this EC2 instance, which is just an image. So that's what I've done here. If you'd like to create an AMI, what you can do is go down to AMIs, and you can see the one that I've created called Docker Web App Demo. So what we'll do is we'll launch an instance from this image. We're going to run this again on a T2 micro instance. We're going to make sure that it's in our new VPC, and we'll put this in the second private subnet. Again, of course, we won't be auto-assigning a public IP to this. We'll keep storage at 8 gigs. I won't worry about tags. And for security group, we're going to select an existing security group, which will be our Web Apps SG that we set up previously. This allows SSH from the dev computer, as well as opening ports 5000 to 5001 from anywhere. And we'll review and launch. So let's go ahead and launch. We'll use the same keys and acknowledge. And our instances are now launching. So if we head back, we can see that this is now in a pending state. If we clear filters, we go ahead and name this one .NET Demo App 2. And while this is pending, let's update our SSH config so that we can SSH into this instance. We need to grab its private IP address and then head back to our terminal. If your terminal happens to be running a connection to your application server, you can Control-C. This is actually going to stop the Docker image from running. That's fine for now. We'll Control-D to exit, so nothing is actually running now on the server. I'm going to open up my SSH config file and put in the correct host name here for Demo App 2. So now we have Demo App 1 and Demo App 2. We can see they're in our two different private subnets. We've got 10.0.1 and 10.0.2. And we can still proxy into either of those from the jump server, which is in our public subnet. So we'll go ahead and exit here, and we'll SSH into Demo App 2. Again, it's going to ask us if we want to add this as an entry to our known hosts. And you can see as an image here that we created from our first app server that we have Docker installed. And in fact, if we list images that we even have the users API set up. So what I'm going to do is I'm going to start our users API on the second app instance, and I'm going to start it on the first app instance just so we can see them both in separate terminals running. So what we'll do is, we're going to use our big Docker run command, and this may be something that you would typically want to write a script for, so you wouldn't have to type this out each time. I'm going to also pass -d. This is going to run it in detached mode. And so you can see we get the container hash back. And so if we just docker ps here, what I want to do is log our this container ID so that we can run docker logs -f to follow the logs, and 83d, which is just the first 3 characters. So this is running. I'm going to open a second terminal now and SSH into our first app instance. And I'll make this smaller. So here we'll SSH into demo app 1. We'll run our docker run command, again with -d this time. We'll docker ps to see that it's running, and I can see that the Docker ID is 891. So I'm going to make this smaller, and we'll say docker logs -f 891, and we can see that our container is now running on our first app instance. All right, so now here's the fun part. We can actually see our load balancer balance traffic against both of our app instances. We need to add our second host to the target group, so let's go ahead and do that now. So we'll come into our load balancers. We see under our listeners here, we can go ahead and look at our target group. And right now, our target group just has a single registered target. Let's go ahead and register our second target. And we'll select this one, included as pending below. And we can see we have an unhealthy health status. Let's check on that in a moment here, but we'll register any pending targets. We can see we're getting health checks failed again, so we can make sure that things are working properly here in a moment. Let's see whether or not the health checks on our second instance are working. Okay, it looks like our second instance is healthy. For some reason, our first instance is not yet healthy. Let's refresh again. Okay, and after a few refreshes, it's healthy. Sometimes it'll be unhealthy for a little while until it gets 5 consecutive positive health checks. And since our application was stopped, we were seeing that it was unhealthy for a time. Okay, so if we head back into the load balancer section, and again we grab our DNS name. I'm going to try to open this up to the left here, and let's see what happens when we hit our endpoint. We should be able to watch logs basically alternate left and right here, confirming that our load balancer is working. So we'll refresh. We see the right side, the left side, and we can see this load balancing round robin style between the 2 EC2 instances in our target group. So we can also configure other types of more complex routing strategies like weighting percentage of traffic to one instance or the other. But this just shows you a very simple, sort of crude example of running our .NET API on 2 separate VMs and setting up an elastic load balancer to balance HTTP traffic against those 2 servers. Okay, so now I'd like to just demo how you might tear down the things that we provisioned here so that you're not paying for things that you're not using if you're just doing this for a tutorial. So we'll head back into our console, and first thing that we're going to do is we're going to terminate any of our running instances. So I'm going to go ahead and shut all these down. We'll go to instance state, terminate instance, terminate all of them. Now keep in mind that our AMI still exists, so if you no longer need the AMI, you can also just delete this. Here we'll deregister. Now we can head back to the EC2 dashboard and we can go to our load balancers. And what we can do is delete our load balancer. So if we go Actions Delete, we will delete our load balancer. Next, we'll head down and, we'll head over to our VPC section. We go to our NAT gateway. Which we can click on here on the left or directly here. And what we'll do is we'll delete this NAT gateway. Now that our NAT gateway is deleting, in a few moments, we should be able to release this elastic IP that we created. This will be grayed out until the NAT gateway is completely deleted. Okay, so now after just a few minutes, we can release this elastic IP address. So this will go back into Amazon's pool of IP addresses. And if we now visit our VPC dashboard, take a look at our VPCs, be sure to select the new VPC that you created and not your default VPC. We definitely only want to get rid of the new VPC that we created, and we're going to go ahead and delete it. If there are any remaining resources that it can't delete, you'll get a warning here or some errors that will show you where to go to delete those. But in our case, this should take care of the resources that we provisioned. It's going to delete the security groups associated with it, including and as well as our subnets and the VPC itself. And so with this, we should be good to go. Be sure to release those elastic IPs and double check that you have terminated any instances, EC2 instances that you created, that there are none running, and that any instances you created are in the terminated state. Okay, so that should be it. If you have any questions at all, please let me know in the comments. Thanks for watching. I'd really appreciate it if you got anything out of this video, if you liked and subscribed, and thanks for watching. I'll see you later.